So good day, everybody. This is Rolf Brink speaking from Asperitas. I'll be presenting the optimized immersion service presentation, in which I'll be showing a spec that Asperitas is open sourcing within the OCP environment. Let me start by giving a little bit of a technology background here. Asperitas is an immersion technology provider, and our basic product is the ASE24, which exists in 15, 19, and 21-inch versions. The Asperitas technology is distinguished by the fact that it's a passive immersion technology, which doesn't require any pumps for the dielectric liquid circulation. The current power densities that we can support go up to 43 kilowatts with dry cool installations, and up to even 60 kilowatts with chilled water, with 2N power delivery to the system, which is fully supported in full redundancy. The compute density figures that this technology can facilitate with these kind of power loads are up to about 45 to 67 kilowatts per square meter, with a solution footprint of 23 to 34 square meters of white space, kilowatts per square meter of white space. And that's all based on relatively high temperature cooling. The Asperitas technology is focused on integration of features. Basically everything that you need to run IT equipment is integrated in the technology. So integrated is approximately 43 kilowatts of power delivery with rack level switch gear fully integrated in the system, and full power management tooling and power management controls for remote management. Cooling wise, it connects directly to facility water systems, and it can control and manage its own cooling requirements, as in flow, the liquid flow, the water that circulates through the system. Everything can be fully managed by the system itself. Everything is also focused on monitoring, so also the thermal and the pressure of the water circuit, the thermal properties and the pressure of the water circuit is fully monitored. The system is equipped with monitoring features, with alarming and logging features, which ensure the full safety of immersion systems in the data center. It doesn't only stop there with the management and telemetry that comes out of the system, but from a mechanical point of view, the solution is fully designed for maximum containment, liquid containment, and thermal containment due to the dual hull design and the full monitoring capabilities of the liquid environment. With full serviceability being a focus, and also a focus on IT optimization. So all the IT equipment which is used in our technology is fully optimized for immersion together with all of our partners. And more on that in the upcoming slides. But one of the fundamental strategic collaborations that we maintain within Asperitas is the one that relates to the immersion liquid. Asperitas uses the Shell immersion cooling fluid, the S5X liquid, which is available for the entire industry, but which has been jointly developed by Asperitas and Shell. And this liquid is fully synthetic and is optimized for immersion cooling, for the immersion cooling application, both for natural convection circulation, as in the Asperitas technology, as well as the mechanical circulator technologies. The liquid is very safe to work with and has a very high purity properties. It meets all of the purity requirements of the European Union and the US pharmaceutical organizations. It has a very low volatility, so it's a very stable liquid. It's non-halogenated, food grade, and free from any kind of allergen. It's also the same base oil is also used as medicinal liquids, which are used in medicines also for consumption. The performance goals with this liquid are mostly focused on the thermodynamic properties. So all the thermal capabilities capabilities of this liquid are optimized for maximum thermal thermal absorption and transport. The liquid doesn't evaporate easily, so the temperatures that are required for to allow the liquid to evaporate are very high. It's a low density liquid, so the weight requirements that follow from it are relatively low, with a weight of 0.8 kilograms per liter, or 0.85, and with a very high flash point. So Asperitas works with flash points well above 200 degrees Celsius. Protection and reliability of this liquid is the properties that relate to protection and reliability are significant. So the liquid has a high compositional consistency, which means it doesn't really degrade easily. So it has a very, very long lifetime. It's got a very high oxidation stability and thermal stability. So Asperitas makes a point of testing everything for very high temperature operation, and we've been running platforms with this liquid with temperatures up to 80 degrees Celsius, which is very high for an IT platform to work with. And the stability of this liquid is very essential to make that possible. There is virtually no sulfur, nitrogen, or aromatics, simply because this is a liquid that is not distilled or refined. This is a liquid which is fully synthetic. More on that in the next slide. But also, very importantly, it's a non-corrosive liquid. So the Shell liquid in this case is manufactured and not refined. So manufactured means that it's manufactured from a natural gas, and it's done with the Shell GTL process, which is an abbreviation for gas to liquid. And in this process, this liquid is manufactured on a molecular level. More information on this can be gotten from Shell directly. So if you're interested in Shell liquids, feel free to contact Shell. I'll be able to share some contact information, and Shell is also part of the Digital Summit. There's the specifications for the liquids that we're using, that we're standardized on, are public information that can be found on our website, but also on the Shell website. But suffice to say that all the properties qualify for the immersion requirements, which are set out in by the immersion community within OCP Advanced Cooling Solutions. So one of the important aspects about the collaboration that we have with Shell is that we focus on monitoring the quality of the liquid, and Shell provides this capability continuously, also with our customer deployments. Especially in our technology center, we make a point of using many different IT configurations in the same liquid, so we can monitor potential pollution or materials that have been dissolved in the liquid. And on a regular basis, we perform an oil analysis, and Shell has the capabilities of monitoring the quality of this oil. And we're also taking oil samples from customer deployments to maintain a track record of what kind of things can happen with the liquid. So far, there has been no evidence of any kind of property degradation that might even remotely affect any kind of IT operation. But the analysis is done nevertheless, and especially when it comes to developing new platforms, new technologies, new specifications for IT equipment, these kind of tests are valuable. And Asperitas is not the only party in the world that Shell can do this with. Of course, any kind of platform provider can set up a collaboration with Shell on these kind of things. So this slide shows a couple of the type of testing that Shell is doing on these type of platforms. Now, within the context of the Asperitas technology, Asperitas is focused on optimizing IT equipment for immersion, and not in a proprietary way. Asperitas is a company that is not creating or selling IT equipment, but to make immersion safe and accessible for the whole world to use. it is important to recognize improvements that can be made to IT equipment to allow any kind of IT manufacturer to benefit from immersion technology. We've decided to open source some of our developments, one of which is an optimized chassis. And this specification has been shared with the community within the immersion calls. So if you want to keep track of these kind of specifications, not only by Asperitas but also from other companies, make sure to join these calls. In this case, what I'm presenting here is the spec by Asperitas regarding an optimized chassis, which is suitable for 15-inch, 19-inch, or 21-inch deployments with 1 or 2U or OpenU form factors. The basic property of this chassis is the fact that it's optimized for liquid flow, as in most server chassis are designed for air and do not allow as much flow through all the hole patterns, through all the gaps, which liquid requires. It is also optimized for servicing. It is completely flexible regarding IT equipment design. It can facilitate virtually any kind of IT combination, and it's suitable for working with C13 power delivery or bus bars. The serviceability, the serviceable design relates to the mechanical lifting interfaces, which are part of the chassis design, but also to the guidance system, which allows you to lower these chassis, this cassette in this case, what we call it, into a slot that is predefined in a rack without getting stuck anywhere. It also contains a toolless protective lid, which can be used to service IT equipment inside. And as mentioned before, it's fully liquid optimized. So part of that optimization for liquid is related to a serviceable side being above liquid levels, which means that all the interfaces can be redirected to a dry area on the chassis. So if you want to have access to cable interfaces, these can be disconnected or connected or attached without getting your hands in the liquid. Then there is flow apertures for liquid. So with liquid cooling, with immersion cooling, a dielectric liquid needs to enter the chassis. There are flow apertures in the chassis, present in the chassis on the sides and on the front and the rear side, at least in the bottom. In the top side, there is outflow apertures on the sides of the chassis. That's because virtually every open bath immersion technology that we're aware of is maintaining a certain type of circulation from the bottom or the sides, with an extraction on the oriented on the side of the IT chassis. In this case, the bottom side of the chassis is also completely opened up to allow maximum liquid inflow. As mentioned, this chassis can incorporate a whole range of IT designs. So what the chassis does not do is this spec does not determine the position of any studs or spaces for electronic components. It only outlines the chassis and how it can be built, and it also includes the actual design files. So from a mechanical point of view, it's a closed box with a removable lid, but the top side of the chassis contains a flexible interface design. So it's contains a separate plate with a hole pattern which can be modified for any kind of interface assembly. The IT design guidelines do apply to the chassis. So there is a separate presentation during the summit that is focused on optimizing IT equipment for immersion, and this specification is fully in line with that white paper. It facilitates material compatibility, facilitates material compatibility outlines in that in that white paper. And within Asperitas, we highly focus on the material compatibility as well as thermal optimization. The concept mechanical design always includes a study on existing assemblies versus optimized. There are big advantages that can be achieved when optimizing for immersion cooling, which is something that we're outlining in that IT gear white paper as well. And this specific specification, as mentioned, can be made in 15-inch, 19-inch, 21-inch, in 1, 2Us or OU compatible formats, and it's completely flexible in component layout. But these need to be considered carefully when it comes to thermal capabilities or material tolerance or flow dynamics. More on that on the next slide. What we also recommend is to do a full build test. What Asperitas can do with developing a chassis based on this open cassette design is full spec testing in our immersion solution. Asperitas offers full thermal analysis services and material compatibility studies for IT specifications. But when it comes to these guidelines of this specific chassis, there's a couple of things to take into account, and this image is also part of the white paper for IT gear optimization. When you make a design for an IT assembly inside a chassis, one of the more important things to consider is the temperature tolerance or the temperature requirements for an end user or for a platform. So servers that are on the market are usually qualified for a certain temperature range of operation within a facility. And this is actually not different when you're looking at immersion. So also to utilize an open cassette like this, one of the things that has to be considered is which thermal performance am I pursuing here. And roughly speaking, for any kind of open bath immersion technology, there is division from cold to warmer area over the that relates to the height to the position inside the liquid from bottom to top, where with the coolest liquid usually being in the bottom, and I'm referring to single phase liquid solutions, by the way, and not dual phase. For single phase liquid solutions, the coolest area is always in the bottom. The middle area of a chassis is usually in some moderate or warmer environment compared to the bottom, whereas the top part of the chassis, especially in this case when it sticks out of the liquid, is usually non-immersed. So there shouldn't be any active components above the liquid level, simply because that is not effectively cooled. So passive components or components with minimal thermal properties can be placed there as long as they have a very high temperature tolerance. So from a construction point of view, Asperitas is standardized on stainless steel. That is because all the products, all the systems that we develop are focused on a very long lifetime and long-term operation in any kind of environment. One of the things that needs to be added to this is, so what we use is a plastic isolation film to protect active components or PCBs and other electronics from the chassis itself, from the open cassette. So we don't want anything to touch any metal to prevent short outs. Any other materials that are used should comply with temperature operations between 10 and 100 degrees Celsius. without excessive change in dimensions. So you can imagine if you're running something very hot, that material might expand, and you don't want to have equipment that is stuck inside a tank. It also has to be tolerant to the dielectric liquid. Now we're using oil, which is a liquid that doesn't have a lot of problems when it comes to metals, but certain other materials like rubbers might be affected by hydrocarbon liquids. So these are things to consider when determining which kind of materials to use to inside the chassis. Another thing to consider is the protection of the dielectric liquid itself. So whatever you insert inside the chassis should not react with the dielectric liquid that is being used, because you don't want to pollute that liquid either. It also should be rigid enough to support IT components. So if a chassis is too flexible, components might be causing shortouts due to malformation of the chassis itself. It also must be able to protect the IT components physically and from electrical damage. So we're working with vertical oriented systems. That means that anything that is accessed from the top shouldn't allow anything to drop down into the electronics, but also it should also protect against electrical damage. Then finally, there should take into account any potential electrochemical potential difference, which should never exceed 0.15 volts. In this case, we're focused on guidance rails. So if this system is to be immersed in a tank which includes an aluminium frame, for example, then using stainless steel as the base material for this open cassette would create a potential difference which is too high, which may actually incur corrosion, especially in the areas above the dielectric liquid. And so it's recommended to maintain material consistency between a tank, or just like you would with a rack, and the materials that are used inside a service chassis. The recommended manufacturing process here is actually fairly straightforward. A standard laser cutting process with press brake bending and brushed finish for aesthetics. One thing is for sure, everybody likes their products to look good, and the brushed finish will do that for you. Now, there's a couple of recommended components that are part of that we like to share with anyone who wants to use this kind of open cassettes or an optimized immersion design. We've been working with Leone for some time, and there are immersion-ready active optical cables. We're also working with some other companies which will be part of the publications later on this year. We've been working very closely with one of the other OCP members, which is 10G Tech, and we've been qualifying their QSFP extenders with speeds up to 100 gigs at 70 degrees Celsius cooling. We're using that together with the Asperitas QSFP extender chassis mounts. So we've developed our own chassis mounts for that, which can be combined with this open chassis. And we are using indium foil as thermal interface material to replace the thermal paste between CPUs or other chips and their respective heatsinks. And more on those heatsinks will be covered in the IT gear optimization presentation. Now, this open chassis is something that we're already working closely together with other manufacturers and other partners in the field. So a list of some collaborations which are currently ongoing are, first of all, with Supermicro. There are several Intel and AMD configurations that we've already built and positioned and sold together with Supermicro and some of their partners. We have in our booth some images of the WeWin configuration, which is a 1U system with three boards with dual Intel scalable compute nodes. There is a Penguin computing, which is a combination with Gigabyte as well, which is focused on a 1U 3 times dual Intel scalable compute node configuration. In the same consortium, there's also a 1U Intel scalable motherboard with as a GPU node. Together with Dell, we're developing a 2U quad node AMD solution, as well now as Intel solutions, which are going to be closely followed on that. With ASE, we have created the first immersion optimized storage system based on NVM platforms, and we're currently working on a 1U AMD Olympus platform. An example collaboration, which we were supposed to be sharing on the physical summit, is one with Supermicro and AMD for a scalable climate independent edge computing solution for telecom providers. Considering the cancellation of the physical Open Summit, the announcement of that is still to be determined. But this is a platform which has been, which is quite unique in many ways as well. So to finish up this presentation, I would like to call upon everybody in the OCP community to also contribute to the ACS Immersion group. Immersion is a field which is spreading and increasing at a very fast pace, which is being adopted at a fast pace. And it's a platform that will benefit from your contributions, from your engagement. Please start using and co-developing optimized IT platforms for immersion, because that's what the immersion requires and what the field requires, what the industry requires, and what is necessary to finally achieve incredibly high efficiency for data centers around the world. More information on this particular development and on the open chassis, open cassettes, feel free to contact Asperitas or join the immersion community and ask your questions there. I hope you enjoyed this presentation, and I would like to thank you for your attendance, and I'm ready for any questions if there are any left. All right. So if there are any questions, I'm here indeed. Feel free to ask them. I'm happy to answer anything that you might want to ask me. And if not, I'll be able to close the session in a few minutes. Okay. Well, thank you everybody for your attendance. Appreciate your attention. Looking forward to seeing you all and meeting you all in the upcoming session. It's starting in half an hour from now, about optimizing IT equipment for immersion. Make sure to attend there. There's much more stuff to be shared in there, and I'm sure that there's plenty of opportunity there to ask more questions. Looking forward to seeing you all there. All right. Bye-bye.